Welcome to ClickMyProject. Our project title is A Mason Test Defenses Against Sybil Attacks in Wireless Networks Without Trusted Authorities. Let us see the abstract of our project. Yes, Sybil nodes in-person nodes others the nodes by broadcasting a messages with a multiple nodes identifiers. The period on reverse RSA information is a proposed to reducing the higher compositional time. It constructed the existing solution with or based on sharing the encryption key. We presented the robust and the lightweight solution of the Sybil attacks problems based on the received signal strength indicator. Reading of messages. Our solution is robust since it is detecting all the Sybil attacks cases with 100% completeness and less than a few presence faults. Our solution is lightweight in the sense that alongside the receiver we need the collaborative and one other nodes. For our protocol, we saw through the experimented that even though the RSSI is a time varying and unreliable in general, and the radio transmission is a non-isotropic using the ratio of RISS the multiple receivers, it is feasible to overcome these problems. Let us see the architecture diagram of our project. First, created the node formation. The node formation creates 30 nodes, and the first node is created, then sent to the period on reverse RSA information. It containing a RSA algorithm, that is encryption and the decryptions. Then the node is valid or invalid in the network is found. If the node is validated, then it does not contain it does not measure any Mason test, means it will go for the Mason test. Otherwise, it will go to the data transmission. The Mason test contain the RSSI validation. RSSI validation is received strength signal indicator. And then the Sybil classification. Sybil classification is nothing but it is that if the node is maybe any attacker node or not detecting the mobile attackers. If the node is not attacker, means it will send to the data transmission. Otherwise, it will be eliminated in the network communication. The data transmission is ends, means the analysis is the results. This is a flow diagram of our project. First, network formation. Here created the 30 nodes, then sent to the routing process. Routing process is nothing but it is where it is the source and the destination. Then the RSA algorithm used for encryption and the decryption. Here the encryption and the decryption key is generated. If the key is generated, means it's good for the RSSI based node identification. If the node is already identified, means it will go for the data transmission. Otherwise it will go to the RSA validation, then the Sybil classification, then detecting the mobile attackers. If the node is attacker, means it will not allowed for the communication. If the node is not attacker node, it is in the already in the network node, means it will send to the data transmission. And then go to the analysis of the results. Let us see the output of our project. First, open the terminal window. Our project coding in Mason folder. So change the directory. The changing the directory code is cd space, then the directory name. The directory name is Mason. Enter. Now change the directory. The root is changed into Mason. Okay. Then now I am running the NS simulator. The NS simulator running coding is NS space main.tcl. Here RSA algorithm is run. First all the nodes are valid or invalid is measured. If the network of the node is valid, means it will allow the communication. If the invalid node is occurred, means it will not allow the communication in the network. Then here encryption and decryption key is generated. The encryption key is applicable for a source node, and the decryption key is only available for the destination node. Here find the position of each node. For example, if the node 6 in 1.92 second, the position of 6 is x value is minus 157.8520 and y axis is 13460. In each every second, all the node position is find here. Now I explain the NAM window. This is our output NAM window, and this button is used for zoom in. This button is used for zoom out. This is stop button. This is play forward button. This is rewind button and play back button. Fast forward button. This is a time simulator, and this is a speed setup. Here I created the nodes. Here I created the 25 nodes. The 25 nodes in static wise. Now I play the NAM window. The sender is 6 and the receiver is 17. That means the source node is 6 and the destination is 17. Period of reverse RSI is start. The period of reverse RSI contain the RSSI values contain the RSI algorithm. RSI to validate the valid node or a invalid node. Here the node ID and the certificate ID is generated. If the node ID and the certificate ID is matched, means the node is valid in our network. If the certificate ID and node ID is invalid, that means this matches means that is invalid in the network. Now find the valid and the invalid nodes. Let's to generate the certificate ID. Now and then with classifying the Sybil classification, and then directing the attacker nodes. Here the 10, 0 and 15, 24, 20 nodes are attacker nodes. So that the nodes are not all in the communication. The 6 and the first neighbor nodes contain 3, 10, 5 bad and the 6 only send the message to the 3, not communication to the 10. The 3 will send the message to the 22, then the 22 node is the source and the 4 is the destination. The communication is at 4, then it will reach at 17. So the possible way is 6 to 3, 3 to 22, then 4 to 17. The destination is reached. Graphs. Here I created the delay graph and the energy graph, then PTR and throughput. First I run the graph and there is a new cloud space, delay, and this is existing system and the proposed system compared with the existing system of the project. Reduce the delay of project. Energy graph, so the command is PNU plot energy graph plot. reduced compared with the existing system. The existing system uses energy high, but in our project reducing the energy, and that means uses of energy uses is low. Next one is a PDR graph. PDR means a packet delivery ratio. The packet delivery ratio graph is run the coding is GNU plot PDRs dot plot. The packet delivery ratio is high when compared with the existing system. The existing system it is a very low, but our project the packet delivery ratio is high. So it is a success of our project. Next one is a throughput graph. The throughput graph formula command is GNU plot thr dot plot. So the throughput of proposed system is high when compared with the existing system.